talking about properties and attributes of polygons. And you might find you know a few of the things we're talking about today already. So first, we are going to define a polygon. So remember that a polygon is a closed plane figure. So closed just means all of the sides are connected, and you are going to have 3 or more line segments. Okay, so closed means all the sides are connected. You are going to have 3 or more line segments, and then each segment is going to intersect exactly 2 other segments only at their endpoints. So we're going to tell whether each figure is a polygon. If it is, then we are going to name it by the number of sides. Okay, so for A, is this one a polygon? Yes. Okay, so polygon. And then, Claire, can you tell me what this polygon is called? Yep, and how do you know it? 6 sides. Okay, so it's a hexagon. It has 6 sides. Okay, so for B, let's review what a polygon is. So it's a closed plane figure. Yep, 3 or more line segments. We have 3 or more where each segment intersects exactly 2 other segments only at their endpoints. Basically, what that means is there's going to be like no curves. So when they're intersecting here, yep, they intersect at your 2 segments at the endpoints, nowhere else. So this is a polygon. And we can even write here. Okay, and how many sides does this have? 7. Does anybody know what it's called? It is a heptagon. Okay, and then for C, because we do have this rounded edge here, this is not a polygon. But it is a very pretty half moon, or crescent moon, really. That's what we would call it. Now, there are special types of polygons, and these are a lot of them are shapes that you see often. They are called regular polygons. If it is a regular polygon, it has 2 very special things. It is equilateral and it is equiangular. Okay, so Ethan, if it's equilateral, what does that mean? If it's equilateral, think of like an equilateral triangle. If a triangle is equilateral, what do we know about it? The sides are equal, right? So if it's equilateral, that means all sides are equal. Or congruent. Right? And then, Matt, what does it mean if they're equiangular? Yep. All the angles are congruent. So what's a very common one that you guys can think of? Okay, we've studied the triangle, and a square is another one, right? You have the 4 angles, all the sides are the same. A polygon can either be concave or convex. If it is concave, it says any part of a diagonal contains points in the exterior of the polygon. If it is, and it says the diagonal of a polygon connects any 2 non-consecutive vertices. Okay, so a polygon is concave if any part of a diagonal contains points in the exterior of the polygon. So the way that you determine what the diagonal is it will connect any two non-consecutive vertices. So not in order. If they were in order and they were connected, what would that be? If the vertices were right next to each other and you connected, what would that be? It would be just the side, right? Like the side of the square. And we'll talk about that when we get down here. So it could also be convex. And it is convex if no diagonal contains points in the exterior. And what we're going to do for our first example is tell whether each polygon is regular or irregular. Tell whether it is concave or convex. Okay, so for the directions, we have to tell if it's regular, irregular, and we have to tell whether it's concave or convex. Yes, Julie.
Wouldn't it be like, isn't concave like when it's on the inside?
The concave, yes, you'll have points where it caves in.
So then why does it say they contain points that are on the exterior?
It's of the diagonal, so we just haven't talked about it with our shape yet. So for part A, the first thing we'll assess is whether it is regular or irregular. So for regular, all the sides are congruent, all the angles are congruent. Are all of my sides congruent here?
No.
Nope, so then it has to be irregular. Okay, let's actually do that with this one too. So are all my sides are the same? Yes, and you're not assuming that. You can tell all the sides are the same because you have the tick marks, right? So all the tick marks are marked the same. Okay, all of the angles are the same. Again, we're not assuming, those are marked for us. You can see they're all marked as right angles. Okay, so this would be regular. Now, I'm going to go over the definition that the book gives for concave and convex, and then we'll kind of talk about ways you can think about it. So concave, it says if any part of the diagonal contains points in the exterior. So if you're thinking about a diagonal, really you can think about any two vertices. Now I could connect these two and it would be in the interior, right? And that would be fine. What they're saying is if you can draw a diagonal outside of the shape that connects two vertices, that's how you know that it is concave. So see how I could draw these here? Yep, that's what makes this concave. Now, a way you can think about it to remember is if it is concave, there are sides that cave in, okay, or they go inside here. But that's what they mean when they're talking about the diagonal contains points when you are connecting two vertices. If you look at the square, right, if I were to draw from this vertice here to any other vertice, the only diagonal I can make is this one, right? Because the other two are right next to it. See how the only diagonal I can make is inside the shape? That's how you know it is convex. Okay, so convex is not going to have like any of these nooks here. Okay, and like I said, here you can draw ones that are inside, yep, but you can also draw all of these diagonals that are outside the shape, which is how you can prove that it's concave. Now, for any regular polygon, they should always be convex, just like our square here. So if you know that the polygon is regular, it's going to be convex. Okay, so if you automatically put regular here, this is going to have to be convex. So that's a nice little shortcut. All right, and then let's flip it over to the back. All right, so the next thing we're going to talk about is the polygon angle sum theorem. So the sum of the interior angle measures of a convex polygon with n sides is going to be n minus 2 times 108. So we have a couple of key words here. Okay, the first one is sum. Okay, so Elizabeth, if I'm talking about the sum, what does that mean I'm going to do? Yep, you're going to be adding some things together. So the sum means we're going to be using addition. Okay, what are we going to add together? Well, it says the sum of the interior angle measures of a convex polygon with n sides, and then we have an equation. We have to understand what the n means, though. So if there are n sides, we can just say n equals the number of sides and then we have an equation. Okay, so if we are going to find the sum of the interior angles all we have to do is take the number of sides, subtract 2, and multiply by 180. Okay, and that's where n is your number of sides. Let's think about why this works with a shape we've talked a lot about this year, the triangle. How many sides does the triangle have? 3. So if I plugged in 3, 3 minus 2 is 1. 1 times 180. Don't we know that all of the angles of a triangle add up to 180? Yep. Another good visual is a square. So if you think of a square, if you cut a square in half, how many triangles do you have? 2, which means the interior angles altogether should be what? So 180 plus 180, which is 360, right? So if I use my formula, 4 minus 2, 2 times 180, 360. See how there are 2 triangles? And that's where your formula comes from. Do you guys know what a 5-sided shape is called? A pentagon. So this is like a regular pentagon. It's as good as it's going to be for now. But if you pick one vertex and make all of your diagonals, see how I have 1, 2, 3 triangles? That's why it's the number of sides minus 2. That's how many triangles are going to be in that shape. Okay? So just in case you ever forget the formula, you can use that. So we have to find the sum for our first example of the interior angles of, find the sum of the interior angles for a convex heptagon. Here's our heptagon again. Okay, so the first thing I like to identify is what my n value is. So if it's a heptagon, we talked about earlier today, that's going to have 7 sides. So then all I have to do is insert 7 into my equation. So 7 minus 2 times 180 means that I'm going to end up multiplying 5 by 180. I'll show you a way we can do this in our head. See how we can ignore the 0 for now? If you want to do 5 times 18, it's just 5 times 10 plus 5 times 8. And what's 5 times 10? 50. And then 5 times 8 is 40, right? 8 times 5 is 40. 10 times 5 is 50. 40 plus 50 is 90. And then you can just add your 0. So it is 900. And that's it. That's the sum of the interior angles. Okay, let's see what our next thing's asking us to do. So this says find the measure of each interior angle. So that's different. See how that is find the sum of all of them? This doesn't say that we're going to find the sum. We have to find each interior angle of a regular 16gon. So all of the shapes with 12 sides and lower have cool names. And once you get past that, 16gon it is. That 12 is a dodecagon. Yes. Based on a deca is 10, and if it's 10 side, it's a decagon. And if it's a dodecadon, it'll be 12. Oh, you know what? I think 11 is an 11gon. We might write down some of what those are. Okay, so this one is different because it's each. So I want us to think about how we can find that. What about for this one? What if they said to find each one? If you know this is all of them together, you can divide by 7. Now, it's only going to work if you have a regular polygon. Can you guys think about why? Because
then you know that all the angle measures are the same.
Yep, exactly. If it's regular, you know all of the angle measures are the same, so then you can divide by the number of sides. Okay, so we're actually going to write an equation here. So if it says to find each interior angle, you are going to do the n minus 2 times 180, but then, like Nia said, here we divided by 7. What is variable is 7 representing? The number of sides, n, and so we're just going to divide by n. And then we're just going to note that this is for any regular polygons. And just to recap again, the reason why it works with regular is because you know all of the angles are the same in a regular polygon, which is why you can use division to find each one. If it's not regular and they ask you to find each angle, they will be labeled with what their proportions are. And we will do that a little bit later. Okay, so if we are going to use this equation, now we can, for a 16gon, our n value would be 16. And really, if you want, you can do this in 2 steps. Sometimes they might ask you to find the sum first. If they asked you to find the sum first, you would do n minus 2 times 180. And then to find each, you divide by n. And then we just have to evaluate. So we're going to do 14 times 180 And we're going to divide it by 16. And sometimes it is a decimal, and that's perfectly fine. All right, so then when you multiply 14 by 180, what do you get? Good, 2,520. So then we're going to take that and divide it by 16. And then did you guys get a whole number or a decimal for this? Yep, good. Ella, what'd you get?
157.5.
Good. Okay, so each angle measure would be 157.5 degrees if it was a regular 16 gun. All right, now our next example, we have to find the measure of each interior angle for this pentagon. So it's not a regular pentagon, but they give you what each angle is, so that's going to help us. The key thing is they told us it was a pentagon, right? How many sides does a pentagon have? 5. So that's going to be your n value. So this one we are going to do in 2 steps. The first thing we have to do is find the sum. Okay, so we have to find the sum of all the interior angles. So we're going to use n minus 2 times 180. We can't just divide it by 5 because it's not regular. So if I plug in 5, I'm going to do 3 times 180. And then I know all together the angles are going to add up to 540. Right, now my second step is I can set up an equation now for all of these angles, because I know that all of the angles added together is equal to 540. Okay, so I know that the measure of angle A plus angle B plus angle C plus angle D plus angle E equals, well, what I just find that it was equal to? 540. Okay, so I'm going to set all of these equal to 540. And then all I have to do is plug in my values. So if A is 35C, I'm going to plug in 35C. B is 18C, bless you. And then we have 32C. D is 32C. And E is 18C. Now, because these all have C in them, they're all like terms, and we're going to add them all up.
Where'd you get 3 times 150?
That. Oh, so the sum of all the angles together is going to be n minus 2 times 180. So because it's a pentagon, you can plug in 5 for the number of sides. And then so your 5 minus 2 is, yeah, where you get your 3. And then you do your 3 times 180. Yep. All right, so now I can add all of my coefficients together. So when I total all those up, good, I should get 135C is equal to 540. And then to solve for C, to get C by itself, I just have to, yep, divide 135 both sides, which means the value of C is going to be 4. Now they ask you to find each interior angle. So this is not finding each interior angle. My last step, yep, is I'm going to have to plug them in. So I'm just going to have to plug them in, and we're going to just do that right on the diagram. Okay, so 35 times 4, I like to do 35 times 2 first, because what's 35 times 2? 70, and then so it's like 70 plus 70, which is 140. Okay, so you're going to plug in C to find each angle. Okay, and then for B, you're doing 18 times 4. I would do 10 times 4 plus 8 times 4, because 10 times 4 is 40. 8 times 4, 32. 32 plus 40 is 72. And then this one is 18C as well, so that will be 72. All right, when I do 32 times 4, I would just do 32 times 2. What's 32 times 2? 64. 64 plus 64 is 128. And those two would be the same. And then you could verify that these are right by adding them all up. And if they equal 540, you know you did everything correct. All right, so everything we just talked about was about the interior angles of a polygon, but we also have a special rule for the exterior angles. And on one of the worksheets you did earlier, you've already investigated this a little bit this year. The sum of the exterior angle measures, one at each vertex, is going to be 360. So your sum of your exterior angle measures is 360. So that's the sum. Okay, and it is the one angle at each vertex. And no matter how many sides it is, it's always going to be 360. Okay, so in a similar way to how we found each interior angle, if I wanted to find each exterior angle, yeah, you know how I do it? What would I do? What do you guys think? I'm going to do 360 and divide it by n. Okay, so whatever the number of sides are, that's going to correlate to the number of exterior angles that you have. So if you're trying to find each, you can take that value and divide by n. So for the first one, you're asked to find the measure of each exterior angle. And it's a regular 20-gon. Which means your n is going to be 20. Okay, so no matter what, all of the angles on the exterior are 360. So we just have to divide 360 by 20. And I would just reduce, really. If you reduce this, the zeros cancel out. What's 36 over 2 going to be? 18. Okay, so each exterior angle is going to be 18 degrees. Okay, and again, if it's regular, we know that each one is going to be the same. If it is not regular, they will give you a picture so you know what your proportions are. And now we can find the value of B. And sometimes they might just say find the value, other times they might say find each measure. But for this, we only have to find the value of B. are what your exterior angles look like. Okay, this is the angle that they're referring to. Okay, so if I added all of those angles together, I would get 360. Yep, and then I will add them all together. So so your sum is 360. And then it doesn't matter where you start. I went in alphabetical order, so I just started at where F was. So 15b plus 18b plus 33b, 16b, 10b, and 28b. I'm finding the value of b, I set it equal to 360. And then, yep, when you add the coefficients, you guys got 120. So 15 plus 18 plus 33 plus 16 plus 10 plus 28 is going to be 120. And then I just have to divide. Okay, so again, if you think of canceling out the zeros, all you have to do is, what's 36 divided by 12? And that's going to be 3. Now, they only ask you to find b, so you don't have to plug those back in, but you could have a question that asks you that. Alright, so I'm going to give you your homework, and then we are going to look at your packet from yesterday.